Good morning to all of you. Friends, let us start with our fourth lecture from paper number 1, Calculus of Several Variables, and unit number 1, Limit and Continuity. Here in this lecture, let us define the neighborhood, as there are two types of neighborhood, circular neighborhood and square neighborhood, and then we will try to define the limit of function of two or more variables. Therefore, very first one, neighborhood of a point. Let us define it one. Let AB be a fixed point in R2. AB be a fixed point in R2 and delta greater than 0. B a number. A delta neighborhood of a point AB is the distance of a point AB from distance of a point AB from the set of points in R2 which is less than delta. It is denoted by n delta AB. Thus, what we have, n delta AB is equal to set of all points in R2 such that distance, x minus k square plus y minus b square is less than delta. This is what we have the definition of neighborhood. Here the point AB is called center and delta is called radius of neighborhood. Okay. This is what we have here. Well, geometrically, it represents the set of all points of all points inside the circle of radius delta and center AB. This is what we have the definition of circular neighborhood of a point in what R2. Okay. Similarly, we can define the square neighborhood of a point in R2. Okay. Therefore, let us have definition of square neighborhood of a point. Okay, let AB be a fixed point in R2, and in the same way delta greater than 0 be a real number. A square delta neighborhood of point AB is the set of all points in R2 such that absolute value of x minus a less than delta, as well as absolute value of y minus b is less than delta. Okay, and here geometrically it represents all the interior points of a square with center AB and sides parallel to the axis, each of which is of length to delta. Each of which is of length to delta. These are what we can have the definitions of square and circular neighborhood of a point AB, which belong to the two-dimensional space, what we call it as xy plane or R2. Okay. Now let us define one more thing in terms of again neighborhood, delicate neighborhood of a point. Delicate neighborhood of a point. Let us have delicate delta NB of a point AB. Okay. Which is useful to define the limit of function of two or more variables, okay, particularly. And these first two definitions, circular neighborhood and square delta neighborhood, these are used to define continuity of function of two or more variables. Now let us define this one. Notation for deviated one, Lx delta AB, and which is nothing but set of all points in R2 such that 0 is less than root x minus a square plus, this is a, plus y minus b square less than delta. This is for what? This is the definition for circular neighborhood. Okay, and square deleted delta neighborhood of point AB. It is nothing but the definition xy belong to R2. Set of all points xy belong to R2. Okay, such that 0 is less than absolute value of x minus a less than delta and 0 is less than y minus b less than delta. This is for square neighborhood. Square deleted delta neighborhood of a point AB, and the point AB as we have considered it one from R2. Okay, and of course point AB lies in the domain of given function to u. Okay, now here we are in position to define limit of a function of two variables. Okay, therefore let us look for the definition of limit, which we have learned in first year BSc. The first definition, or what we call it as epsilon delta definition of limit. Similar way, in second year BSc also, we need to learn the definition of limit. What we call it as epsilon delta definition. Well, let us define it one. Let f of xy be a function of two variables x and y. Two variables x and y. Okay, comma AB be any point in the domain of f, in the domain of f, and in deleted delta neighborhood of and is, not in, and is a deleted neighborhood of point AB for f. And again, L is a real number. L is a real number. Okay, if this is there, then L is said to be a limit of a function f of xy as point xy approaches to AB. Okay, if when we say that L is a limit, if for every epsilon greater than 0, we can find delta greater than 0 such that absolute value of f of x comma y minus L less than epsilon whenever 0 is less than absolute value of x minus r. Here let us have
square deleted delta negative x minus a square plus y minus b square less than delta.
Let us have definition. Let f of xy be a function of two variables, x and y, and a be any point in the domain of f, and and let us consider the deleted delta neighborhood of point AB. Okay. L, any real number, we said that L is the limit of a function of two variables x and y as the point xy approaches to point AB. If for given epsilon greater than 0, we can find out delta greater than 0 such that absolute value of f of xy minus L less than epsilon whenever this happens. Similarly, you can have the definition of this one, or one can write the definition here, or right, or okay, or this same thing happen. Absolute value of f of xy minus L less than epsilon whenever 0 is less than absolute value of x minus a less than delta, and 0 is less than absolute value of y minus b less than delta. Okay. If this happens, then we can say that L is the limit of a given function f of xy as xy approaches to AB. Okay. Now this thing, it is denoted by limit x comma y tends to AB of f of xy is equal to L, or here you can have limit x tends to A, y tends to B of f of xy, okay, is equal to L. And this thing, as here we are taking x tends to A, y tends to B, x tends to A and y tends to B at the same time, and therefore this limit is also known as, okay, this limit is also known as simultaneous limit. Why simultaneous? Because here at the same time x, we are considering x approaches to A and y approaches to B, and that is why it is known as one simultaneous limit. Okay. Well, now let us have the same way definition for limit of function of three variables. Okay. How will you define one? Okay. Can anybody imagine it one? Or can you give me the definition of limit of function of three variable? Okay. If not, let us have it one again. Okay. Definition of limit of function of three variables. Okay. Function of three variables. Let's say f of x comma y comma z. As we need a function of three variables, therefore let us consider f is a function of three variables, x, y and z. Okay. Instead of writing each and everything, let us write a function f of x, y, z, a function f of x, y, z is said to have limit n. Okay. If for every epsilon greater than 0,
we can find out delta greater than 0 such that absolute value of f of x comma y comma z minus L, which is less than epsilon, whenever 0 is less than, let us define circular neighborhood x minus a square plus y minus b square. This is for a function of two variable. Now, as here our function is of three variable, therefore let us add one more here, z minus c square. Okay, this will be less than delta. Okay, and this thing similar to this one, function of two variable, we can write it as, okay, or denote it as limit x y z tends to point now a b c of the function x y z is equal to L, or what we have, limit x tends to a, y tends to b, z tends to c of function x y z, that is equal to L.
Okay, this is what we have the definition of limit of function of three variables. Okay, now we may go for here in this way. You may go for the definition of function of more variables, as we have seen here for function of two variables and three variables. Okay. Now, let me say, give a sketch here. Okay. For examples of this one, by using definition and all these things, we will go separately for the examples, or in the next lecture we will go for the examples. But here, let me illustrate or sketch the circular neighborhood of a point which belong to R2 and square neighborhood of a point which belong to R2. Of course, and we have used those things to define the limit of a function of two variables, therefore deleted delta, circular and square neighborhood. Okay. Now let us have here, as we have, this is what the two-dimensional frame of reference. This is the origin. I mean, this is our one. All this one is our R2. Right? All this thing. Now let us consider this point AB. Okay. As over this one, over this R2, okay, a function f of xy is defined. Okay, and therefore let AB be a point in the domain of this function, and which is, say, this is what? All this one we consider it as a domain of function R2, and we are considering this point AB, any point here in this domain, which is also a point of R2. Now let us define, let us take delta, fix some delta, say delta is equal to 1, okay, CM or whatever may be, unit, you can have delta is equal to 1, and therefore if I have here this much is my delta, this much is my delta, then I can have here the set of all points which are around this one. Okay. This gives me everywhere here it is what? It is nothing but this is what we call it as delta. And all these points which are on the boundary of this one, which I have shown by dotted line, this gives me, this is nothing but what? It's a circular, yeah, delta NBD neighborhood of point AB.
Okay, and if I am not considering this point AB, which I am going to remove it one, I am considering this one only, right? This part, okay, which are inside this circular part or circle, which has no boundary, and therefore we can have here the distance is greater than 0.